Welcome to the Grid Mod Pod, brought to you by AEIC. In this podcast, you'll hear from the utility industry's top operations leaders on how their companies are working to modernize and improve our ever-evolving power grid. Thanks for joining us.
Welcome back, listeners, to the Grid Mod Pod. We have another guest coming on to talk about one of my favorite topics, which I'm going to start having a poll with some of our listeners on what they all believe my favorite topic is. But today, we're going to talk about all things integrated system planning. And I'm just going to caveat with a little bit of an operations perspective. But anyway, today we have Carlo, who is the CEO of encoord, a software package that really has the opportunity to unlock some capabilities that we talk a lot about here on the Grid Mod Pod. So with that, thank you for taking the time to come on the Grid Mod Pod and share where you're coming from, your perspective. So let's give the audience an opportunity to hear from you and introduce yourself.
Thank you very much, Liz, for the invitation. It's a pleasure to join this podcast. My name is Carlo Brancucci. I'm the CEO and co-founder of encoord. I'm based actually in Colorado, in the United States. And I've been working on the topic of integrated planning for the last 8 years or so. In my previous job, I used to work at the National Renewable Energy Lab. I started working on this topic, looking at the need to integrate across electricity and gas planning. And that's what drove me to found encoord in 2019, together with the original inventor of our integrated planning solution, Saint, Kwabena Tambour. Now, since we founded encoord, we have further developed Saint as an integrated planning solution, not just across electricity and gas, but more importantly, across the electric vertical. So integrating planning across generation, transmission, and distribution.
Yes. And so just for our listeners, and maybe any new listeners that just found the Grid Mod Pod, the energy sector as a whole is going through a significant transformation. And this word transformation, just like the word grid modernization, is quite buzzwordy. However, what it means is there's an enormous amount of new tools and technologies that are becoming available for the grid operators and or planners to have access to. So that is opening the floodgates of how we distribute the electrons into every individual home differently. And so as that is transforming, the traditional planning methods that the utility folk, not only just electric, but really gas and there's the water and the sewage and really just public infrastructure is changing at a very rapid rate, right? And so in this discussion, I think, we're going to focus on the space of integrated planning, and where you and I met, I think was a really cool space because we were at ESIG, Energy System Integration Group, which was running, their 2-day technical spring conference. And we were on a panel together around integrated system planning. And I think what we both learned, and we already probably knew this, but there's many terms and definitions of what that is, right? Which I think is quite the challenge in all areas of this transformation is what is the language we're using and how are we quantifying, qualifying those certain work streams. So here I am going to ask your first question. How is, from your knowledge, and I love your background, that a traditional approach to electricity or electric utility planning evolving in regards to these new challenges I kind of shared, but I didn't specifically say them to give you the opportunity to dive in.
Thank you very much, Liz. So I would say what is challenging the traditional way of planning the system is first the integration of new variable technologies that includes renewables, that includes storage, but also the fact that change in the power system is happening much more rapidly than it has over the last several decades. We have impacts from electrification of other sectors like transportation, as an example, that is increasing the way we consume and the amount of power we consume. Also, large loads from data centers with the growing needs from artificial intelligence, but also aging infrastructure. So I'll give you an example. We've been talking to many utilities that are facing the challenge of preparing for the retirement of large, for instance, coal power plants that have driven a bulk part of their total generation for decades, and at the same time replacing them with a combination of renewable storage and gas, thermal generation, and at the same time, which actually are going to be located at different locations than where the original soon to be retired coal or other thermal plant is today, and at the same time dealing with large increases in demands, for instance, dealing with interconnection requests to interconnect gigawatts of data center demand. That means the entire operation of the system is going to look very different 10 years from now than it looks today, and even more different than it looked 10 years ago. And that is impacting not just the way we dispatch our generation to meet demand, but the way electricity flows across the transmission network, which will probably need to be upgraded significantly, but also across our distribution network that traditionally saw power flowing from central generation through transmission networks down to distribution networks that will then distribute the load in a unidirectional manner to the customers. Now we have a distribution network that is significantly more active. We have active customers, active assets in the distribution system that are causing electricity to flow in both directions, from the downstream low voltage distribution network to the upstream medium and high voltage transmission network, and vice versa. Now, for many good reasons, the power system has been planned, let's say, in silos, where generation was planned by one organization or one team, transmission by a different one, and distribution by a separate one. And that has worked really well for many years. But now all these new changes that we are experiencing require these planning processes, and more importantly, planning teams to interact with one another. And that is challenging for many reasons. And I will argue the first challenge is people. It's hard to coordinate your processes with teams and organizations you haven't had the need to coordinate with before. There is even an element of trust where it is hard to trust the work someone else does if you're not familiar with it or you don't understand the need for it. And then obviously there are several other challenges of integrating these complex planning processes, such as the process itself and the regulatory requirements that often drive these processes that may not be aligned themselves, as well as tools and data. And obviously the latter part is where I spend most of my time developing software solutions that can help utilities and system operators integrate across these planning processes.
So many threads to pull there. So, coming from also a planning background, and for our listeners, like peeling back the onion, you mentioned the infamous word silos. So when we think integrated, the idea is that we want to integrate the various silos to drive, develop, and create more of a collaborative, cohesive awareness of each other. And I think one soapbox that I like to get on, I'll do it real quickly, is, we've all been learners in a world of silos, like really given a particular course with a particular curriculum, and you just kind of march down, solve the problems, the end. And what I think holistically has been missing from an educational, informative development realm of being is that we all work within systems of systems. So, which we'll get into, kind of, and I'm going to the question of kind of the evolution of like where you were and then how you came to be, right? There was like a journey in itself of like why you were able to think through and create said tool. But like one differentiation that I learned from that panel is like integrated system planning is there's the planning within the utility internal folk themselves. So how are you integrating those various silos? And I've talked about them a lot on this podcast, but you have your planning and forecasting, you have your operational reliability, you have your asset management, you have your engineering design limitations, then you have your, kind of walls around procurement and what's able and capable and affordable, all the way into like executing and making it, easily usable to the field, right? So that's a whole span. So when we think of traditional planning, it was, those that chose the original capacity capability was really the driver across all of those units that I just spoke of, right?
Yeah.
But on top of all this technology being different and behaving different and having, various characteristics that were originally around when this first traditional method approached, you didn't need all of that complexity because you just built the grid to meet the future forecast, which was increasing. So when you say integrated, specifically in this conversation, we're talking about that integration. But I did hear you mention gas. Is there there's a lot of utilities that are being asked, right, to integrate the future development of the electrical grid with the evolution and future of the gas infrastructure needed for the grid.
Yeah.
And one more, and then I'll let you answer. Then we also have this thing called telecom, where all of these devices and how they interact on the actual physical wires and transformers and switches need to communicate. So there's another grid per se. You got your telecommunications, you have your distribution of fuel sources, so not only gas, but all of the various fuel sources, as well as the poles, wires, and transformers. So that's complex in itself, but this integrated planning from a variable perspective of just electron flow is complex in itself, right? So I guess that's where, what space are you kind of sitting in when we think about creating solutions for all of the parts to ultimately impact the larger parts?
Yeah, absolutely. So first of all, the term integrated means different things for different people and different organizations and different regulatory environments. So many of us have heard about integrated resource planning, integrated distribution planning, integrated energy planning, integrated transmission planning, integrated system planning. At encoord, we refer to it as integrated planning and on purpose. And what we mean by integrated planning is the coordination between traditionally siloed planning processes or planning processes that are meant to answer different questions, measure different metrics, achieve different objectives. And this could be integrating generation and transmission planning or transmission and distribution planning, but it could also mean integrating economic planning or economic driven planning with reliability driven planning, which often is actually the case when we look at generation and transmission. Generation planning is often driven by building the least cost generation resource mix to meet future demands, while transmission planning is often driven by reliability. Build up the transmission system to operate reliably and under secure conditions. So in such a way that the operation of the system can sustain the loss of one or two generators. But it could also mean this integration across traditionally siloed processes could also be across electricity and gas. And so I'll take a couple minutes to talk about this because while it's not necessarily the main focus of encoord today, it remains an important aspect of what we do with our customers and the uniqueness of what we offer. And also it highlights the history of encoord and where we started. The electric system, the grid, interacts with the gas infrastructure in two ways. The first way is through gas-fired generators. In the United States, about 40% of electricity is generated from gas generators. That means that there are parts of the country and times of the year where that percentage is significantly higher. There are parts of the country where gas represents 80 or more percent of electric generation. There are times of the day or the year where that represents even higher, up to 100%. There isn't a single gas-fired power plant in the continental United States that stores gas that I am aware of. And actually, if anyone is listening to this podcast and knows one that does, please reach out because I'd love to know, because I keep making this statement and no one has disagreed yet to it. Which means that every gas-fired power plant, in order to generate electricity, depends on the pipeline network ability to deliver gas at the right time, at the right pressure level. And that sometimes can be challenging. Most times, during most conditions and most days of the year, that is totally fine. Gas networks are designed to deliver gas in large quantities at the right pressure level to gas-fired power plants. But as we integrate renewables and we start impacting the way gas-fired power plants operate, meaning we're starting to operate them in a more variable fashion, that ramping up and down can create pressure-driven constraints on the gas pipeline networks and may limit their ability to meet the power system needs. In addition to that, there are scenarios when the gas pipeline network is under stress, such as extreme cold events, like the ones we've seen in different parts of the United States just during the last 5 years, where there is an event of very cold temperatures that can last multiple days, where there is an enormous need to deliver demand for heating to keep people warm in their homes. And at the same time, there may be a need to increase electric gas-fired generation. And now we have gas that is in competition between heating for LDCs, for gas utility companies that need to deliver gas for heating to their customers, and gas for electric generators, which often don't have firm contracts. And so there is a conflict there. And being able to coordinate the planning and operation of these two infrastructures is key to ensure we can maintain reliability and delivery of energy, especially during these extreme weather events. And we have seen in Texas, for example, a few years ago, how there may have been a cascading effect where the electric grid had to cut delivery of power to electric-driven, for instance, compressor stations, potentially, that had limited the ability of the gas network to compress gas and therefore deliver it to gas-fired generators that then caused the inability of the gas generators to deliver power. And obviously, I'm not familiar with the details of the Texas event, and so I don't want to make any claims about what exactly caused that event. But clearly, it was a display of the interdependency of the two infrastructures. The challenge we have as a community is that there is no entity today that I am aware of in the US that is in charge or has the authority to coordinate the planning across these critical infrastructures. There has been several public statements from FERC and NERC in the past calling for the electric and gas industry to coordinate better, and especially around these extreme weather events or other extreme events, so that the power system can really understand how dependent it is from the gas infrastructure and quantify the risks it may be subject to under situations where there is a major contingency on the gas side. I strongly believe that many electric system operators are not able today to quantify the risk because they don't have full visibility on the potential loss of a gas network asset and how that will impact their ability to maintain operations on the electric side due to the reduction in electric gas-fired generation. So that's the first one. The challenge we have there to engage with customers is there is no one today that we've met, apart from research organizations, but in the real industrial setting, that has the right data about their electric and their electric network together with the data of the gas pipeline networks that deliver gas to their gas-fired generators to purposefully model these scenarios and prepare for them. And that can be different operational constraints during extreme events or potentially investments in new capacity or new flexibility in either system to be better prepared for events where the interdependency of these systems is critical. The second way these sectors integrate is through customers. There is a driver to potentially explore the opportunities to electrify gas customers. That could have a benefit on the gas side to reduce or avoid the cost of upgrading gas infrastructure that may be leak prone, it may be outdated, or it simply requires upgrade because demand is growing. There are obviously associated decarbonization benefits that come with it. Now, the cost of electrification is obviously in terms of appliances, but from a grid perspective is, do I need to upgrade my grid infrastructure to meet this additional demand. And so in this respect, we're actually working with utilities in the US where they are using SAIN to integrate electric and gas planning to evaluate opportunities for electrification and target regions of their overlapping territory where there may be an interesting opportunity to electrify gas customers that is overall beneficial for the system.
So when we think, so old planning methods just don't work anymore. And I think that is trending. Traditional methods of planning are fundamentally outdated because they don't take into account new energy sources, such as the dynamic customer load at the edge, but as well as, we get caught up in intermittent or inverter-based resources, and we then talk about electric vehicle preparedness, but really also the core infrastructure systems that we've known to be in existence as long as the grid, which is your gas, water, and, all those other communications, etc. So, and I kind of love this, but it helps and it will help individual leaders, executors, doers to have access and visibility to many sets of data that can be integrated in a way that provides this insight that we've never had before, right? So there's a genuine gap in the leadership that are in charge of making this progress because those disparate data sets that have been siloed, however big you want to go, right? Now with the software, the hardware, and our powerful computational world that we've now created, we have access to maybe start connecting those dots, right? And creating better decisions to drive overall investment, which is the goal. Is people are being asked what to do, when, and how quickly, and what's it going to cost. So I guess it leads to, in your world of where you were kind of trying to answer and develop and provide support as a helper, you evolved into this capability, right, of doing so. So I guess, can you tell a little bit about like the thought process of what originally, we heard really where we're coming from, but like now what is becoming available to those that are aware that this change needs to occur?
Yeah, and I will say, so while I do strongly believe that traditional planning processes don't fully meet the needs of today's power system, they are the foundation that we need to build on. They are the planning processes that have got us to where we are, which is a pretty reliable system. I can only count very few times in my life where I lost access to power, and it's been for a very short amount of time. Clearly, I'm originally from Spain, and there was a major blackout last week in Spain that affected a lot of my family and friends. I'm pretty familiar with this. And it was a clear reminder of why we need to adapt and evolve our planning processes to better understand how our system will behave under unknown scenarios that did not represent the operation of the system in the past.
Right.
Now,
I guess I would, that is a really big topic that I think will become a large space of lessons learned. And I actually just came out of a very long storm response where I sit when we lost power for multiple days in an area that we fundamentally don't get this type of weather. It was 45 minutes. It was a snap right through the territory, and it was just trees down everywhere. So like from a loss of power, we have a significant amount of vegetation and there's a significant amount of overhead, and it is the grid that we built. And so it takes time and people to cut down the trees and rewire the system. Whereas that's a distribution response to elements outside your control and really hard to plan for, if not you can't, right? That's a whole reliability resiliency. Right? What you just spoke of with the large scale outage was from a bulk electric system cascading phenomena. And we've learned a lot from like the 2003 Northeast blackout, 2009 San Diego, the recent ERCOT. It's not just one contributor, right? It's multiple variables that kind of line up for the perfect storm, no pun intended. So yeah, it'll be very interesting. And we can't jump to conclusions. And I think the worst thing we can do is put language around something that we don't understand the full analysis of it. Not that we were, but maybe to all our listeners, there's more to come, and it's such a complex, situation that we're talking seconds time frame, right? So just being aware of how important it is to have the data, have the visibility, and understanding the physical response of these very large machines. So I guess, breaking it down maybe for some of our nerds, like there's traditional methods which we developed. I mean, what is power systems? It's a complex array of mathematical equations that we have defined words and language and units to quantify power, voltage, current, right? Frequency, timescales, right? It's all in there. And so when we think of power system analyses and when we think of planning studies, and I broke this down in one of my other grid mod pods, but you have timescale phenomena, right? You have level of data granularity that is required. And so you can go from a very small study of like the interactions of a circuit breaker opening and closing from a large system event that requires a certain model to like these very large system models for the transmission. 3-phased balanced stability, right, is your key versus your distribution, which is single phase unbalanced, or we would love it to be balanced system. So it's different buckets of data just to study a system response, let alone all of those complex integrated other pieces of data that needs to be like embedded. So from your perspective, I mean, how have you broken down and then build up, and in what area to kind of help move the needle in the direction of the integrated plan that we're talking about?
Yeah.
I'll just say, when I heard you talk, it's very mathematically complex. And I think we haven't led into that, and we don't want to like put anyone to sleep, but I think it's really powerful to people understand that this isn't just like a simple equation. I mean, this is very computationally heavy.
Yeah, absolutely. And you bring a very good point. One is the data challenge, and second is that there is only one power system that is a large interconnected system. And so the approach we've taken at encoord is you may use different mathematical models to solve for different problems or to meet different planning requirements. So you may have, without getting into too many details, a production cost model of your generation system to plan for generation. You may have a power flow simulation for planning for transmission, and then unbalanced power flow for planning for distribution. But ultimately, you are still modeling and planning the same system. You are just focusing at different spatial and temporal scales. And so what the approach we've taken at encoord is to develop a single data structure that applies to all. So you can have a single data model of your system where you will, and when you run models for different planning purposes, you're only pulling the data that is required for that mathematical modeling approach. But now you have a consistent data set. So now if I want to iterate between transmission and distribution planning, or I want to iterate between economic and reliability planning of my transmission system, I can do that with a consistent data set. This solves a major challenge in the industry, which is that different planning areas are planning their system with tools that rely on inconsistent data structures and formats. And so when they start coordinating their planning processes, the process breaks down because these tools and these data sets were never meant to be interoperable and work with one another.
So where do we go from here? No. For those listeners, I think, one is clarifying the terms that you're using and ensuring the audience that you're communicating with is clear, right? I think it's something we overlook in a lot of spaces, not just integrated planning. But, what's your kind of, from your journey and where you guys are and where you're sitting to help support, this evolving industry, what are some words of wisdom or key takeaways that you've kind of observed and would like to share with the audience?
Absolutely.
We could talk all day if we wanted to get really geeky, right? So
I would say, well, first I want to mention a recent effort that me and the encoord team have been involved with EASIG, actually, where you and I met, Liz. EASIG has created a year ago an integrated planning task force, which includes planning experts from utility system operators, consulting firms, and research organizations and others, where we got together to discuss the need for integrated planning and solutions for integrated planning processes and technologies. We were involved in the task force by leading the development of an integrated planning guidebook that will be released in the summer. It will be a public document, and it is aimed at utility planners to learn how can they approach in a practical way and in a step-by-step approach integrating planning processes within their organization. One thing we learned through the development of the guidebook is that communication and shared and common understanding is the first step in integrating across any two planning processes. So I will say, where do we go from here? Well, encourage planners and industry leaders to be curious, to learn about the other planning areas and to try to understand how are they planning their system and why are they planning it in such ways. The other thing I will add, and I will end with that, is that for technology innovation companies like encoord, what is very important for us is to really understand where utilities are today, how they are planning the system today, what is actually working, what is starting to break, and build solutions that are founded on the planning processes today. The way we plan system properly is by really knowing our system. And if we go to planners that have been in the utility for 10, 20, 30 years, and we tell them, well, the way you've been doing it for the last 10 to 30 years is the wrong way. Here is how you should do it. And I'm going to overhaul your 10 planning processes with one massive new planning tool. It's never going to be adopted and it's not going to solve the problem. It's just going to create more problems. So our approach is working with utilities to understand where they are today and offer solutions that build one step at a time from where they are. So one way we are doing that is, for instance, giving them the ability to take their planning modeling data sets they use today and implementing them directly in an automated way in our software, and then enabling that iteration between not just different planning processes, but different planning tools as well. That is going to be key to engage with utility planners and encourage them to try new solutions, try new technology without disrupting the existing process. And slowly they will adopt and innovate and end up with the solutions that meet the needs of the future.
I love it. So yes, I mean, I think the power of our industry is our ability to bring the experts together and share core functions and practicalities to develop something such as what EASIG and your team and all of the experts really have created to then deliver to those planning organizations that have yet to get started or yet to feel challenged. I'm coming from a space where, trying to drive a culture and a strategy in a space where it has yet to become a reality is going to happen to everyone ultimately, right? Like our grid is changing no matter where the adoption of or what the original driver is. There's now so much changing. It's not just one particular technology. It's this idea of customer expectations, the ability to scale new technologies, and fundamentally, we are creating something from nothing, but with the awareness of the history that we've seen it happen before. So it's like such an expansive space. So creating tools like what you just shared is really incredibly valuable. So thank you for that contribution. I look forward to diving in and sharing it with our members. And then I think another thing I love that you said, and I think is really important, is, this industry, we have the utility asset owners and operators that are held to regulation for safe, number one, reliable, affordable, and now more recently sustainable, resilient delivery of power. And that requires people. So we need people. We need a workforce of a generation of workers that understand that complexity. But we also need the vendors, the solution makers, the R&D to do a lot of the futuristic leaning in. And then you're right. Once you have the solution, it might be the perfect solution. Remembering that integration of the two sides of the people is in itself work, but work that can provide progress, which I think is very purposeful. So the more that we can be partners in this industry instead of like vendors or, selling a commodity, like we're really truly selling the people aspect of how do we do it together, because we're going to need a lot, right? Every system is unique in itself. We over here in the United States, we got 3,000 of these individual, I rounded up, distribution grids. We have like 1,000 transmission grids, and they all have a set of leaders, engineers, innovators, and ownership. So how do we create that culture is really the key to, I think, grid mods. So you led me right into it, and I didn't even bake you. Well, thanks so much for showing up. And again, I look forward to the release of your document and also hearing more about your collaborative work with the utilities that you are working with. So,
thank you, Liz. It was a pleasure and appreciate it.
That's a wrap for this week's episode of the Grid Mod Pod. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode soon. Until then, keep powering on.